The Wave Lab got started really with kind of the vision of offshore wind energy that we've had of kind of breaking into that market and providing better floating structure alternatives and trying to make offshore wind happen.
The University of Maine has been making great strides in the area of ocean engineering. Maine's flagship university has recently completed the Harold Alfond W² Ocean Engineering Laboratory, a $13.8 million project that will be able to test the capabilities of many floating structures, like ships and aquaculture facilities, at a scale of 1 to 50.
We ended up going to the Marin test facility in the Netherlands because they were the only ones who could really accommodate the added component of having wind along with waves. And even then, their added component was just a giant bank of fans that was stationary. But we found that it was really an open opportunity for us because most of those testing facilities in the world are booked out years in advance. It's expensive to go there, and they didn't have all the things that we were looking for in a test program. So we kind of, the way that we typically do things around here is, well, if it's not working out hiring someone else, let's figure out how to do it ourselves.
The Advanced Structures and Composites Center, located on the University of Maine campus, is known for performing research in many areas, from wood composites to defense and aerospace. But with the addition of their newest wind and wave generating facility, Libby says the center will be able to provide more valuable research to the Department of Energy.
One of the unique parts of this facility is going to be the wind tunnel, in that not only is it going to be a fully calibrated functioning wind tunnel rather than just a bank of fans, but the eventual goal is to have that move so we can actually move it during testing, which no other facility in the world can do combined wind and wave testing with the wind and the waves moving during the test and changing during the test.
There are many parts that go into creating waves at the W² facility, so let me show you how it all works. The basin floor has a working depth, meaning it can be moved up or down to influence the waves. It has a maximum depth of 16.4 feet. A wave maker made up of 16 individual paddles is capable of generating waves at a maximum height of 2 feet. The paddles can also move in unison or be adjusted to create waves at different angles. The wind tunnel can generate winds up to 16 miles per hour. As Libby said, it will eventually be able to move along a rail system to simulate changes in wind direction. The basin is also equipped with a beach to diffuse the waves, much like a shoreline would.
It's a very custom shape. It starts as kind of like a nice parabola, and then it tapers off very quickly. And it's been designed so that the range of waves we can generate, no matter what's in that range, we only have a minimal reflection of like less than 5%.
Libby says, although there is still much to be done, the facility has already had many clients come for testing.
4 weeks ago, we had our first client come in and actually did a week-long testing campaign with them. And we're actually gearing up right now for our second client. We're involved in a national testing competition where we and several other testing basins have a series of 40 wave energy conversion candidates that we are doing the tests on behalf of the Department of Energy.
The center is expecting W² to be around for a long time and to be an important part of research at the university. And although it is still new, it has already been receiving plenty of attention.
While working on this, we've had 4 or 5 other companies come out with different prototypes and things they want to test. Some of them are just looking at using like this